In this video, we're going to continue with parametric equations. This time we're going to talking about the area under a parametric curve. So the example we have is we want to find the area under the curve of the cyclic defined by the equations. So the cycloid function or graph is actually a way to, it is a graph to tracing the path of a ball rolling on the ground. So the ball is going to travel, like for example, like a wheel or something, right? So when we're looking at a wheel by itself, it's just like the wheel is going to travel this direction. It looks like we're just drawing a circle, but in the actual situations, while the car is moving, there's a distance. So even though it's actually moving this way, but it's not actually always here along this circle, it's actually going to move more like, these versions. So that is the cycloid graph. But for this problem, it's not really, it is important, but it's not too important because we have the equations here. We have the two equations for the parametric equations, and we want to find the area under it. So what we're going to do, according to the formula, the area of the parametric equation is going to be an integral from a to b, y of t multiplied by x prime of t dt, where the a and b is going to be our interval 0 to 2 pi. The y of t is 1 minus cosine of t, and then the derivative of x of t, which is just going to be one minus cosine of t. So we're going to multiply them. And we do not know how to find the antiderivative of cosine squared, so we're going to using the identities to rewrite cosine square of t as 1 plus cosine 2t over 2. Simplify it a little bit more, because here is a 1/2. And then the 1 in the front, we can combine them to get 3/2. Then the antiderivative is going to be 3t over 2 minus 2 sine of t plus sine of 2t over 4, and then we're going to evaluate it from 0 to 2 pi, which is going to be 6 pi over 2 minus 2 times sine of 2 pi is going to be a 0. Sine of 2 pi is going to be a 0. So we got 3 pi as the final answer. So for parametric equation, finding the areas, making sure that you remember the formula for the areas. And then you know that because we're working with parametric equations, both x and y's are functions of t. You're going to apply chain rule. And the rest of them is just more like straightforward or regular integration problem.